we know that the results of an experiment can be the same or can vary if we perform the same experiment a number of times. For example, the sum of the measures of the angles of a quadrilateral is 360 degrees. Consider the quadrilaterals shown here. Let's measure the angles of the quadrilaterals using a protractor. On adding all four angles of each quadrilateral, we see that the sum is 360 degrees, and that this is true for all quadrilaterals. Thus, in such types of experiments, the result can be predicted, and it will be the same for any number of trials. In the counterpart, let's look at another example where a die is rolled 10 times. The possible results are 1, 2, 3, 4, 5, and 6. Here, it is quite impossible to predict the result if the die is rolled once again. It could be any number from 1 to 6. Such experiments are called random experiments. Mathematically, a random experiment is an experiment that has more than one possible result, and it is not possible to predict the result in advance. The result of each trial is called an outcome, and the collection of all such possible outcomes is called the sample space. Many a times, we want to know how many times an outcome occurs in an experiment. For example, in tossing two coins, we may want the number of heads that appear. In rolling two dice, we may want the sum of the numbers on the two dice. In an experiment of drawing 3 balls at random from an urn containing 6 blue and 7 red balls, we may want to know the number of blue balls in the sample of 3 balls. In all the cases, a rule can be assigned to each outcome of the experiment, so that the outcome is a real number. For example, in the first example, the number of heads that appear in an outcome could be 2, 1, or 0. Similarly, in the second example, the sum of the numbers in an outcome could be 2, 3, 4, and so on till 12. In the third example, the number of blue balls in an outcome could be 0, 1, 2, or 3. In all the cases, the real number associated with each outcome is not fixed. This real number varies depending on the different outcomes of the experiments. In other words, this value depends on the random experiment, and hence it is called a random variable. Generally, it is denoted by the capital letter X. Let's review again the experiment in which 2 coins are tossed. The outcomes are HH, HT, TH, and TT. Thus, the sample space of the experiment is as shown. Let's assign a rule, the number of heads that appear. If X denotes the number of heads that appear, then the number of heads that appear in outcome HH or X of HH is 2, X of HT is 1, X of TH is 1, and X of TT is 0. Similarly, we can also define another rule, the number of tails that appear by a random variable y. The value of y for each outcome is shown. Likewise, for a random experiment, we can define many rules. We can compare random variable x with a function whose domain is the set of outcomes or the sample space of a random experiment. And the codomain is the set of real numbers, because x can take only real numbers. Hence, a random variable can be defined as a real valued function whose domain is the sample space of a random experiment.